Hi, this is Lo. I'm here recording another Minecraft video, using it to help, I guess, review and go over math concepts with you guys. Basically, today we're going to be talking about triangles a lot, specifically right triangles, and using them to calculate a bunch of different things. Then we're going to apply that to measure the height of the firework that we're going to shoot later on today in this video. So, uh, first of all, triangles have 6 pieces of information, right? That they hold. Essentially, they have 3 sides and 3 angles. And um, basically, for a right triangle specifically, if you know the lengths or any of the angles, you can essentially calculate a lot of different things about this, any triangle really. But with specifically right triangle, it's really easy because there's really basic functions that can really help you out. Anyways, let's kind of define some of the aspects of a triangle really quickly. So, first of all, let's cover the easy ones, right? So, the longest side is always going to be the hypotenuse, and this will always be uh, the length that is, I guess, directly across from the right angle, right? So, if you can locate your right angle, you know that whatever's at the other side is always the hypotenuse, and that never changes. So this hypotenuse never changes. Now, you have 2 side lengths, right? And depending on what you're going to do with whatever function you're choosing and whatever angles you have information on, essentially what it's going to do is define how you can use these side or the lengths that correspond to them. So like let's say I chose let's look at this right here. Ooh, not that button. You see right over here, this is an angle. It is the green angle. And basically because we chose this angle, this red side is now called the adjacent. It is the one that is touching the angle that is not the hypotenuse. And this orange length is now the opposite, right? It's the side that is opposite of the green angle. So if we go over here, it's the exact opposite. If we chose the pink angle, right, this now becomes the adjacent because that is the side that is touching the angle that is not the hypotenuse. And if we look for the opposite, it's the one that is opposite of the pink angle. So this red length is now the opposite. Now, there's this thing called SOHCAHTOA. Essentially, what it is they're functions that are cyclic in nature. Basically, you know how you ride a bicycle? Every time you pedal, or every few times you pedal, the bike and the way it turns and everything, it creates a pattern. And these patterns happen over and over and over again. Now, all these functions are made of patterns that are inherent to right triangles. So as long as you know an angle and some of the information about the sides, or you know all the information about the sides, you basically can calculate anything about any right triangle. Now, I will go over the specific math in the actual math portion. Just know that for SOHCAHTOA, for pretty much the first letter of each of these words stand for what function they are. So S is for sine, C is for cosine, T is for tangent, and the second 2 letters of each one of these, I guess, words are essentially the ratio you make. So for so, it is always, so let's say we're using the green, whatever sine of this angle will always be equal to the opposite divided by the hypotenuse, right? So their lengths divided, basically a ratio. Same thing with cosine. It's the adjacent divided by the hypotenuse. And for a tangent, it's the opposite divided by the adjacent. So that's how that works. So a little bit about this structure I built really quickly. I am allowing it to turn into nighttime because, we're about to see some beautiful fireworks. But essentially, I I have measured out this distance. It is 47 blocks. 47 blocks from this pressure plate to that dispenser over there, right? So that is our adjacent. We are basically standing there, and when the firework goes up, we're going to look at it, right? And pretty much our line of sight will be the hypotenuse, and we are trying to measure the height. Now, I looked on the Minecraft wiki, and essentially fireworks go up a specific height, depending on their flight duration, plus or minus about 5 blocks. So, uh, you know, every time you watch a firework go up, it's necessarily going to pop in the same spot. But what we're going to do is essentially calculate, how high a specific one goes. And the way we're going to do that, right, is if you hit F3 on your computer screen, you'll notice that we actually have a spot that gives us our angles. Now, if you look on the left, you go down to where, right below chunk, you'll see facing, right? And as you see me look around, you'll see that the numbers at the very right of facing changes, right? Now I'm kind of looking at the horizon, so that's why the number all the way to the right is really close to, 0. If I look a little up or a little down, you'll notice that that number changes. Now, if I look side to side, you'll see the one to the right, to the left, that changes as well. Now, in Minecraft, it's a little weird, and it happens in a lot of games like this. When you look up, it actually counts that as a negative number, but it's okay. We'll just take this number and we'll just throw out that negative sign. It doesn't really matter because we're looking up, and that's not really what we're doing. So we can use that negative 24.2, wherever that negative 20, you know what I was talking about, that specific number in our measurement. So if I jump on this pressure pad, I watch this firework go up, aim towards the middle, I could use that 18.8 as pretty much a number to calculate everything on. So let's do another one, okay? So jump on the pressure plate. It popped right up there. So 26.1. That is our number. So I just got to remember 26.1, and that's the number we're going to calculate on. Now, the only other number we need is that it's 47 blocks away. But yeah, I'll meet you back on the actual chalkboard where I can essentially do the actual math itself. Welcome back to the classroom. Right now, I drew a triangle so everyone could see what we're doing. So here's our measurement. This is our angle, 26.1. And here is the adjacent, right? Because that is the side touching our angle. So remember, let's label this out now. So we have our angle. So this is the adjacent. This is the hypotenuse, right? It's all across from the right angle. And we have our opposite over here. Now we're trying to find the height of our fireworks. So we're trying to actually find the value or the length of the opposite, right? So that is what we're really looking for, the length of the opposite. So essentially we're going to look through SOHCAHTOA, and we're going to see which ones have anything to do with the opposite in them. So TOA has the opposite in it, and SO has the opposite in it. So we're not going to use KA. And now we're going to think about how do we want to do this. Do we know the length of the hypotenuse? We do not know the length of the hypotenuse. So we're going to cross this one out too. So we're going to essentially use the tangent. So remember how I described it was basically the function, and this is the fraction that they cause. So what that means is tangent of some angle. So in this case, I'm going to use theta. That's a common variable we use for angles in math. That's going to equal opposite over adjacent. Essentially, that also happens for, ka and so, or sine and cosine. It's just instead of, opposite over adjacent, this one would be adjacent over hypotenuse and opposite over hypotenuse. So we're going to use this one. We actually have our adjacent, which is 47. So we have a 47 here. But we're actually just interested in solving for the opposite. So we could take this over here, right? And what we're going to do is essentially just multiply it by the adjacent. So we have the adjacent multiplied by whatever the tangent of the angle is going to give us the length of our opposite. So that will give us the height of the firework. So essentially we have 47 times tangent of the angle 26.1. So you can throw that in your calculator really quickly. The number I got doing this was, mind you, I round, so 23.02. There's no reason I specifically rounded to the second decimal place. It's just a place I stopped. Now, this would be the right answer, but we got to remember one thing about Minecraft and one thing about real life as well, is that depending on how you're measuring can affect your numbers. So you got to remember, our player character in Minecraft is about 2 blocks tall, right? So the angle that he's actually staring at it at is actually a little off. Basically, what I'm trying to say is if we're up here staring at, I guess, the firework, we're actually 2 blocks off the ground. So there's a length of 2 here, or about 2 anyways. So this will translate across, right, to the opposite side. So actually it's the opposite plus 2. So in this specific case, we have to take into account the height of the player character in Minecraft. But there's a lot of occasions where this is not going to happen. Like when you do a lot of stuff with math just involving triangles and you're not, involving heights of people or anything like that, that this would be true. This would be the final answer. But just because of the fact that we have to take into account the player height, we're going to add 2, which is about 25 blocks. So our firework went at least 25 blocks up. And remember, I started at the middle, so technically the particles that went the highest went quite a bit further away as well. Maybe even like an extra block up. But yeah, I hope that you learned something today. Thank you for your time. Thank you for watching.